Hello and welcome to Tech of the Day. Today's video is really interesting to watch, and please continue watching till the end. We are going to talk about how Amazon Prime Videos, a service which may monitor audio video streams, reduced their cost by 90%. At Prime Video, they offer thousands of live streams to their customers to ensure that customers seamlessly receive content. Prime Video set up a tool to monitor every stream viewed by customers. This tool allows them to automatically identify perceptual quality issues, for example, block corruption or audio video sync problems, and then it triggers a process to fix them. Their video quality analysis team at Prime Video already owned a tool for audio video quality inspection. Okay, but they never intended or nor designed it to run at high scale. Their target was to monitor thousands of concurrent streams and grow that number over time. While onboarding more streams to the service, they noticed that running the infrastructure at high scale was very expensive. They noticed that scaling bottleneck that prevented them from monitoring thousands of streams. So they took a step back at the architecture of the existing service, focusing on the cost and scaling bottlenecks. So we are going to discuss this architecture in detail and how they did it. Actually, this is very interesting to know because they moved back from distributed systems back to monolithic application, and still they gained 90% of the cost, which is really interesting. So the initial version of their service consisted of distributed components that were orchestrated by AWS step functions. The two most expensive operations in terms of cost were the orchestration workflow and when data passed between distributed components. To address this, they moved all the components into a single process to keep the data transfer within the process memory, which also simplified the orchestration logic because they compiled all the operations into a single process. They could rely on scalable Amazon Elastic Compute Cloud EC2 or ECS, Amazon Elastic Container Service instances for deployment. And this was the architecture they had. Their service consists of three major components: the media converter. I will their service consists of three major things. The media converter, which converts input audio video streams to frames or decrypted audio buffers that are sent to detectors. Okay, defect detectors execute algorithms that analyze frames and audio buffers in real time, looking for defects such as video freeze, block corruption, audio video synchronization problems, and then send real time notifications whenever a defect is found. So from real time notifications are sent whenever a defect is found, and these are the detectors they have. The, the third component provides the orchestration that controls the flow in the service. And they designed their initial solution as distributed systems using serverless components, for example, AWS step function or Azure function, like in Azure, if we talk about distributed systems or serverless functions, serverless compute, and which was a good choice for building the service quickly. In theory, this would allow them to scale each service component independently. However, the way they used some components caused them to hit a hard scaling limit at around 5% of the expected load. Also, the overall cost for all this building blocks was too high to accept the solution at a large scale, because they built it for in the beginning they built it for the small audience, because Amazon Prime was not that big at that time, and they didn't realize this problem at that time, and it was too quick to easily to develop, so they chose this solution. And also it was following up distributed design, which is a modern term to use. So it this seemed no problem. The main scaling bottleneck in the architecture was the orchestration management that was implemented using AWS step function. Their service performed multiple state transitions for every second of the stream. They quickly reached account limits. And beside that, AWS step function charges users per state transition. Okay. So, and the second cost problem they discovered was about the way they were passing video frames images around different components. To reduce computationally expensive video conversion jobs, they built a microservice that splits videos into frames and temporarily upload images to Amazon Simple Storage Service S3 bucket. And then the defect detectors, where each of them also runs as a separate microservice, then download the images and then processed it concurrently using AWS Lambda. However, the high number of tier 1 calls to S3 bucket was expensive. So overall, this architecture was really pain in the system. So to address the bottleneck, they initially considered fixing problems separately to reduce cost and increase scaling capabilities. They experimented and took a bold decision. They decided to re-architect the whole infrastructure. They realized that distributed approach wasn't bringing a lot of benefits in their specific use case. So they packed all of the components into a single process. This eliminated the need for S3 bucket as the intermediate storage for video frames, because their data transfer now happened in the memory. So they also implemented orchestration that controls component within a single instance. So basically they took a bold decision to move a distributed system to a monolithic application. And this looked something like this. Conceptually, the high-level architecture remained the same. They still have exactly the same components as they had in the initial design: media conversion, detectors, or the orchestration. This allowed them to reuse a lot of code and quickly migrate to a new architecture. In his initial design, they could scale several detectors horizontally, as each of them ran as a separate microservice. So adding a new detector required creating a new microservice and plug it into the orchestration. However, in their new approach, the number of detectors only scale vertically, because they all run within the same instance. Their team regularly adds more detectors to the service, and they already exceeded the capacity of a single instance. So to overcome this problem, they cloned the service multiple times and parameterizing each copy with a different subset of detectors. They also implemented a lightweight orchestration layer to distribute customer requests. Basically, because yeah, these days every company has these type of problems, and we don't think much about this, and we just move to highly talked of topics. And many mistakes we do, and one of them is not thinking about scaling of your solution, because we take cloud for granted. We say, okay, cloud has this ability to scale itself, auto scale, and we don't think about the consequences of auto scaling. It might have some throttling, or it might have some costs added to it. So we don't think about it at all. So the key takeaway: microservices and serverless components are tools that do work at high scale, but whether to use them over monolith has to be made on a case-to-case basis. Moving their services to monolith reduced infrastructure cost by over 90%. It also increased their scaling capabilities. Today, they are able to handle thousands of streams, and they still have capacity to scale the service even further. Moving the solution to Amazon EC2 and Amazon ECS also allowed them to use the EC2 computing service plan, and that will help drive cost down even further. So some decisions they have taken are not obvious, but these decisions resulted in significant improvements. For example, they replicated a computationally expensive media conversion process and placed it closer to the detectors, whereas running media conversion once and caching its outcome might be considered to be cheaper option. They found this not to be cost effective approach, and the changes they have made allow Prime Video to monitor all the streams viewed by their customers, and not just the ones with the highest number of viewers. This approach results in even higher quality and better customer experience. So you are scaling down the cost and improving the customer experience. This is what is called proper architecting. So the key takeaway here is not only to think about your architecture before moving to cloud or doing anything, or upgrading your services from monolith to distributed systems or serverless applications, but to think about case to case about your application itself. That's it for today, guys. Thank you for watching Tech of the Day. Please like, share, and subscribe this video. Thank you. Bye bye.